Okay, hi everyone. First of all, let me thank you for attending our presentation. Me, Julian, and my colleague Diogo, we will be talking about, as you can see, from an interior to a microservice-based architecture to cope with the electric mobility shift in Europe. Okay, so moving on. So this, let me introduce ourselves. My name is Julian Andrade, as you can see. So I'm currently a business area manager working at Link Consulting for more than already 10 years. I've been focused on integrations, web development, and AI. And I will be co-presenting today along with my colleague, Diogo Rodrigues. That is currently a technical manager of cloud projects at our unit, our business unit, ICE, and he also has the responsibility of the cloud service portfolio. So, trying to briefly explain, sorry, first of all, let me just introduce Link Consulting. I forgot about that. So Link Consulting is a global technology company with more than 20 years already, specialized in digital transformation, enterprise architecture, enterprise integrations, and cloud-native solutions for web and mobile development. And especially in the last couple of years, or in the last years, we have been focusing our efforts, let's say, in the Middle East market and also the European markets as well. We have been focusing our expertise and our power, creating value for our clients, especially in this enterprise and event-driven architectures projects, and especially in this case with Solace as our partner. Okay, so this is the context for about Link Consulting. And speaking, going straight to the context of our presentation. Trying to briefly explain what we are doing at the moment. So the adoption of electric vehicles continues to grow. These are the trends today. This is the trend today. And it's important to address a couple of problems or issues that we currently deal with. So as you can see, we have a couple of problems that we try to address. And especially the risk of proliferation of private networks is one of them. The pressure on the electric grid that is currently growing up indefinitely, and all the companies feel that at the moment is one of the other issues. Also, the charging stations, the number of charging stations that are in our public roads is growing and growing even more. And obviously, one of the main causes of this is more and more electric cars being used and getting sold as the time being. So taking these problems in consideration, we have 1, 2, 3 solutions that we came and we are addressing. So one of them is smart charging. So trying to charge cars and use the electric grid even better in a more intelligent way. The other one is obviously the profit of the different players in the market. So that's also one of the solutions we have. And obviously, as we have standard protocols already built and we are using them, the interoperability of them is also really important to deal with. So these are the main problems and solutions that we came up with them. Okay, so now what we're seeing is basically an overview of our architecture, or the solution that we are taking in place and we built. It's basically built on top of 3 main modules, the ones that we are seeing at the moment. So as you know, the market is changing. The European market is changing related to electric mobility. So taking into consideration the problem that I mentioned on the other slide, and the solutions that we have, basically we mounted this diagram and this architecture to support the solution that we are already implementing in several of our clients. So basically, the solution is, as we can see, mounted on the top of these three main modules: the AMSP, e-mobility service providers; the CPO, the charging point operators; the hub module that basically allows the communication between parts. These three ones basically support support our solution. So for all of you guys that are not so aware of these names and these acronyms, basically the MSP is who owns typically the service and provides a service to the end user or the client, if you want. Okay, so basically we have companies like in Portugal, like Prio, ADP, for example, and outside on a global scale, you have like, for example, Shell is one of them, and basically they provide the service in the end with the EMSP, like as the EMSP. Then we have also the CPO module. Basically, these are the charging points operator that are responsible for the charging point. And as you know, Portugal, I can mention a couple of them, like Siemens or the group DISA, DSA. And outside Portugal and global market, we have like ABB as one of the responsibilities. And obviously, we also have the hub, where all these entities are connected and where we do all these broadcasting information between a CPO and the EMSP. Okay, so for example, I can give you an example about one of these companies. Like in Portugal, we have Mobi-e, outside we have Girev and Abject. Okay, so basically, these three modules, they make all our solution possible. We use the protocol OCPI that is a standard protocol that it was built, and we make possible. It's possible using this protocol that we mounted the solution, the smart charging solution, and you can also see 2-3 points on the diagram that it's about smart charging and the enterprise module that we also built. So speaking about the smart charging flexibility module, the solution allow public electric grid operators to make some adjustments or adaptations when peak usage is being generated. And so, as you know, the OCPI protocol generates a lot of information. So we pick up that information and we aggregate it all and make it available through events and files using the Solace event broker in a fast manner. Okay, so basically, with the pressure on the grid, a lot of issues came across, and basically this smart charging flexibility module allows for all these operators to gather all the information and make smart decisions, try to proceed and distribute the energy in a smart way to the decision makers in the end. Okay, and basically we need to always usually work with this distribution system operators like E-Redes in Portugal or Iberdrola in Spain to make this possible. And then basically on your bottom left, you have the OCPP modules where basically the communication protocol between the charging points and the communication that we need to provide to the CPO is basically provided there. So it's a specific firmware that charging points have. We have a protocol, standard protocol to communicate with. In the end, we provide a solution where we also provide an app, mobile app, a white label mobile app, and a back office that manage all of these parts of the solution. Okay, so in this last slide for my part are basically the standards that I would like you to keep in mind. So the three main standard protocols are the OCPI that I mentioned on the other slide. That basically is the interface for the standard mobility electrical standard. And we have the OCPP, the Open Charge Point Protocol, and the OSCP, Open Smart Charging Protocol that you should take in consideration. The other three protocols and the other three standards are still being implemented. Currently, we are working on them, and we don't have them ready in the solution, but we are working on them. And so that's basically what I would like to deliver to you today. So Diogo, please, I will get over back to you.
Hi, everyone. Thank you, Julian. So basically, I will start to present the technical approach that we had to migrate from NT architecture to an event-driven architecture. We started with an architecture where currently exists one legacy hub, which we call a legacy hub, that is represented as a black box for us, where basically all the charging stations and all the e-mobility service providers and all the legacy processes that are running to support the national grid nowadays in Portugal, this needs to be migrated because of the challenges and because of the problems that Julian explained before. There are a lot of concerns and a lot of new standards that needs to be implemented. And basically, we are building a solution to migrate from entire platform to a microservices architecture and event-driven architecture. This means that basically we want to migrate from this approach here to this approach. And basically, this represents that we are building microservices, a lot of microservices to implement the different protocols and the different functionalities that we need to integrate in our new platform. Our new platform is basically built on top of a microservice and event-driven architecture. And this platform delivers a set of APIs to integrate with the charging stations and with the MSPs and CPOs, and we also deliver a backend application for the end users, being able to manage the charging stations and their integrations with the CPOs and MSPs. Our protocols are the protocols that we are implementing as default standards for the market. And for example, looking for those CPI protocol, we have a set of modules that we implement, like location, CDRs, versions, sessions, etc., that are entities recognized by the protocol, and we implement that as a microservice because their information can be managed in a single application like a microservice. Okay, we also have the LCPP microservices that implements all the other interfaces to communicate with the charging points. Okay, interfaces, for example, to receive messages like boot notifications, status notifications, meter values, and things like this. Okay, and basically we are also implementing the broadcast microservice. This broadcast microservice is a microservice that the main reason for its existence is basically to broadcast the information to the MSPs and providers and CPOs, sorry. This means that, for example, when I put one location in charging, I need to broadcast this information to the other CPOs and MSPs just to let them know that that location is not available on the network. Okay, and this is as isn't to be for our challenge here. And going to the next slide, basically here we have a challenge that is converting OCPP messages that are messages related to the charging point, like heartbeats, meter values, status notification, starting sessions, and things like this. It means that are things related with technical messages into OCPI messages. OCPI messages are basically more related with business interfaces, okay? So we need, for this, we are receiving the messages from the charging station in a microservice, okay? We treat this message and then we publish this message to the event broker. This means that all the microservices, OCPI microservices related, they will consume this message and provide the information to the end users through the broadcast microservice in a standardized way for the OCPI protocol, okay? And here, the event broker is one of the key components of our architecture, because we can, in an asynchronous way, send and consume events without direct communication between microservices. Basically, one of the most used protocols in our solution, as we explained before, is the OCPI protocol. And if you read the OCPI protocol, you can see that there are many entities on the protocol, like locations, which is the module responsible to manage all the charging stations that are connected to the network, sessions that manage all the sessions, the charging sessions that occurs in the locations, tariffs to manage tariffs, tokens to manage the RFID cards, and the applications that are allowed to start new transactions from the commons. So basically, all of these entities and all of these modules that are represented as a microservices, they are all connected to the Solace PubSub Plus. It means that all the communications and all the changes that occurs in each one of these modules will publish a message to the event broker, and the other microservice will consume the message when it's needed for their correct functioning. Thinking about the event-driven architecture, this is a very high-level architecture that we are used to implement on our projects related to the electric mobility. So basically, we have an API gateway just to expose the APIs for the other applications and for the stakeholders. We have also the cross-cutting components like the back offices, mobile apps, user portals, other components to manage tokens and cards. We have also the observability component that includes all the tools to monitor, tracing, and audit our architecture. And we have the core components that are represented as microservices. This means that for us that our microservices usually don't communicate in a synchronous ways between each other. They will always publish and consume messages from the event broker, okay? This means that, for example, in a simple use case, when I put my car into a charging station, I will receive a message from the charging point that will be published to the event broker saying that in this location, this connector is in usage. And for example, another customer wants to start a new session in this location, and the sessions module needs to know that it can allow or disallow the user to start this new session. And based on the previous messages, the session module will consume the message from the location, and he knows that this location is in usage. Based on this, he will refuse the connection for a new session, okay? And this is the way that we are implementing the things. Here, the event broker is also very important because it implements a lot of patterns that allow us to, for example, external applications communicate directly with the event broker, even the charging point, because charging point are communicating using the WebSockets method. We have also the opportunity to integrate with the service bus, for example, through the REST APIs integration, okay? And why Solace is a big advantage for our solution? This is a big advantage because we are implementing different patterns and different strategies using Solace that allow us to make high scalable and very performant solutions for our market. As you know, for example, most of our microservices are implemented in a Kubernetes solution. And this means that to represent a microservice, I can have a deployment, and this deployment can have multiple replicas. It means that we have a lot of pods representing the same deployment. And if I publish a message to a topic and all of these pods are consuming the message from the topic, the message will be consumed many times. So here we are implementing the topic to queue pattern using Solace because we publish to the topic and then the microservices are consuming from the queue. And in this way, we can guarantee that the message is consumed just one time, okay, for one of the pods of the deployment. We are also using the topic hierarchy, which is very important because, for example, if I want to send a message saying that the connector on the charging point ABC is in usage, I publish the message for the topic under the location ID. Okay, so basically I can put the message on the /location /ABC, which is the code of the location, /connectors, and I will publish the message to that. It is very important because in this way we can just consume the relevant messages from the relevant topics. Okay, we have also the opportunity to use replay messages because here the platform that we are implementing and that we are moving to production is a very critical platform that manages all the charging points in the public network here in Portugal. And if one simple message fail, we need to replay the message just to process the invoice, for example, for the end user. Another relevant topic is the high throughput that Solace can deliver to us. We have a lot of charging points connected to the solution, and we need to manage all the information coming from different charging points. And if we don't have high throughput on this broadcast of the messages, it will be a showstopper for us. So having this delivered by Solace, this high throughput, it's very relevant because in a couple of milliseconds or less, we have the message broadcasted to the different microservices, and each microservice can treat the message in a parallel and produce the relevant outputs. Finally, with the event broker, in this case Solace, we have the ability to transform some synchronous protocols like REST APIs or REST integrations into a sync pattern. So basically, by for example, publish a message to a specific topic, I can have the ability to consume this message and integrate this with a service bus, for example, which is very important for some patterns of the protocols that we are implementing. What are the next steps for the project and considering the Solace functionalities and benefits that we are exploring? So basically, we have three main points. The next step that we are trying to implement is having the charging points connected to the Solace broker, because charging points are connected through WebSockets. Currently, we have a microservice, which is a WebSocket to receive these connections, but we are trying to move all the charging points to being connected to the Solace broker directly through the WebSocket integration. We are also implementing the new version of OCPP 2.0.1, and this is a new version of the protocol that integrates with the charging points. But this protocol is now prepared for some async patterns, and we want to explore this protocol based on Solace benefits. And thinking that the Solace is a very good platform and it's high throughput on broadcasting the messages, it is very important to integrate here the third step, which is explore the data. Because of this, or considering this, we are trying to push for some data analytics tools to integrate with Solace, just to consume the information from the broker and analyze it, and then provide new business data models to analyze new different metrics, new different data patterns and things like this, just to think about for new tariffs that can be applied on the charging points, new patterns of usage, just to increase or decrease some power usage on some specific points and things like this. And finally, we have the last slide where we want to explain to you what makes us different in the market. Why Link is different in the market right now. So basically, we are implementing multiple cloud solutions and cloud native applications. And in all of our solutions that we are implementing, 90% of the use cases that we are implementing, we are using an event broker. In this case, we are always using Solace. We consider that this is a must-have a tool that we need to include in our architectures, because its throughput and its advantages are very relevant for the patterns that we are implementing when we are implementing cloud native applications. And this is very relevant for the market, because we can guarantee scalable solutions, resilient solutions, and very performant solutions, okay? In the other hand, we have very knowledge and very experience on migrating critical systems. So basically now we are focused on the electric mobility market, but we have also other use cases, like for example in public transportation, where we migrate from legacy applications running on end-tier architecture, and we moved the solution to event-driven and microservice architecture without any kind of issue, improving the scalability and improving the performance of the solution, and all of this without disruption for the end user. And this is the main differentiator for the market, and all of this based on the core component, which was Solace Event Broker. And that's it. Thank you, guys. Thank you, Tim. Thank you, Julian. And if you have any questions, please put them on the chat. We will try to reply all the questions. Thank you.